Hello, my name is Michael Weir and welcome to this special discussion on electrification and specifically the findings of a recent study that looked at the commercial and technical viability of a battery electric vehicle fleet as an alternative to a diesel fleet at IGO's Cosmos nickel mine in Western Australia. I'm joined by a panel of experts today. Chris joined IGO in 2017 and has more than 35 years experience, largely in underground mining across a range of styles, commodities and mining. Darren has more than 20 years of experience in mining and more than 10 years in technology and electrification related positions. Mirzad has nearly 30 years experience in mining and electrification. Gentlemen, welcome and thank you for joining us today.
Thank you.
Chris, we'll start with you. What was the background to the study and why did you choose Cosmos as an example for full electrification?
The background of the study was we wanted to make our mine safer, greener and more productive. That was our why. The how was through mine electrification. The thing about the Cosmos mine was that it had a shaft. It enabled us to get away from the problems with battery electric trucks and their limited range. They would need to change batteries on every trip to the surface. By going to the shaft, we managed to eliminate that altogether. So it made a great candidate to be all electric.
So why did you get Perenti involved?
Well, we've had a long-term relationship with Perenti's subsidiary Barminco for many years. They were the original miners at Flying Fox and at Nova, and they've been at Cosmos since the beginning. So they know the mine well, and we know each other well. We both have similar views on wanting to decarbonise and electrify. Because of that, we've been able to harness their relationship with ABB as well. So the three of us together have done a study that we don't think anybody else has done, listening to the market. This has enabled us to pull all the parts together to try and understand not just how you change a diesel gear for electric, but all the systems and all the thinking that goes with making that happen.
Thanks, Chris. Darren, Perenti headed up the study. How challenging was it and what was the approach?
The approach was one that sort of fell in line with a pre-feasibility study, a traditional mining pre-feasibility study. And that is we wanted to understand what factors would really change in an electric mine. So we took into account fleet selection, which is the obvious change. However, we looked into mine design, scheduling, we looked at how we would distribute power, how we would generate power, operating philosophies, our operating practices, which again would play a big part in how successful we are once we built this electric mine. But the fundamentals is what we first looked at, and we believe that moving forward with those fundamentals, we could execute well.
Chris, going back to you, the big question, I guess, how close are we to full electrification?
Well, we're a lot closer than we thought at the start of the study. What we found is that we can find equivalent vehicles that are either available now or will be soon that we think will be just as productive as a diesel gear under some fairly conservative assumptions. So they may well beat that. We think the cost base is pretty good, as well as the safety case and the ESG case. We thought we were within about 6% on net present cost between the two different options. So that's not far to close that gap up. And the overall power consumption looks to be less, which seems counterintuitive, but because we can save on ventilation and refrigeration, we actually get all the energy for moving the mobile fleet for free.
So it really does sound like an electrified fleet is a real possibility in the not too distant future. Mirzad, bringing yourself and ABB into the discussion, the study found that power consumption of an electrified mine at Cosmos was less than that of the existing diesel operations. What were the key drivers of this finding, and what impact might that have on the infrastructure that's required to transition?
Actually, the study shows that the total power consumption is calculated less than equivalent diesel operation. That is due to the significant reduction of the power consumption in general, and that is actually coming from a reduction in the size of the ventilation and cooling system. It says us if we take actually electrified fleet for any new greenfield project, expected to result of significant reduction of size of the ventilation and cooling system. The reason for that is that all of us know that the electrification system is more efficient compared to a kind of internal combustion engine. And from the other side, we all know that all the diesel-based equipment generating a lot of heat and emission. Therefore, we need very extensive ventilation system to remove the heat and bring the fresh air, while by minimizing the emission in electrified fleet and also reducing the heat that they generate, we come to a significant reduction of the size of the ventilation and cooling system when we are using the electrified fleet system.
Chris, back to you. The study also suggests that there is some battery electric vehicle equipment on the market at the moment that matches the productivity of diesel equipment, but it's not that extensive.
No, we looked at it in three categories. We had our heavy vehicles, being trucks and loaders. They have very high energy needs. There are very few of those available on the market at the moment in frontline applications, so we would have to trust that they're going to work until we can trial them first. There's ancillary equipment, there's a lot of that available at the moment, and they're starting to get a few in various operations. We have a couple through Barminco at our Nova mine site. And then there's the light vehicles, and there's a number of different battery chemistries and lengths of capacity of the battery and ruggedness and very different price points. So we could mix and match a fleet of that. But certainly our conclusion was that if the equipment turns up and performs as the OEMs expect it will, we should easily be able to change diesel to electric for pretty much the same number of units. And once we get to use them, I'm pretty confident we're going to find they're better than what the OEMs are telling us they might be.
Darren, Barminco's been a leader in testing some of these vehicles at various operations. Tell us how those trials have gone.
I think as a whole, they've gone very, very well. We've always anticipated that this is a new part of the market and that there'll be some teething pains throughout all of the fleet. However, as a whole, considering all of those factors, I think the OEMs have responded very well.
What are you doing at Nova?
So we've had a great opportunity to trial 7 different types of machines at Nova, and that includes everything from light vehicles all the way up to some of the ancillary fleets as well. The commitment of IGO to allow us to bring these new machines to site has been phenomenal, and it gives us again that opportunity to use a playground to be able to test these machines and gather data.
And what about in terms of drilling equipment?
Yeah, so we recently commissioned into production a long hole drill, and it's exciting for a couple of reasons. One, it is battery electric and it's performing very, very well as a frontline drill. But interestingly, we're also getting an additional benefit in that we are now able to surface remote that drill, which gives us additional productivity from that machine.
Mirzad, just back to you. Can you speak to the role that ABB is playing in these emerging spaces and why collaborations like the one between ABB Perenti and IGO are so important to drive the industry forward?
First of all, I should say that ABB is forefront in developing actually advanced technology for all electric mine and answering to a specific needs of operation in underground mining and open pit in its actually decarbonization solution. And this portfolio consisting of the trolley system and also charging solution that we have, but not limited these two, we're more or less trying to help our customer to manage the energy transition in the mining business in the near future. One of the other things that I wanted to mention is that collaboration with our alliances, that actually we customize the technical solution fit to the requirement of the operation in all electric mine. In the same time, we are taking into account the different aspects of the mine, for example, the depths of the mine, size of the mine, and actually nominal production that the customer have in mind to reach. The other things that I can say is collaboration with the Perenti and IGO. It's continuous feedback that we could receive from IGO and Perenti to fine-tune our solution to be more reliable and effective in the market and actually be more acceptable to the rest of the market in all electric mine. Out of collaboration with IGO and Perenti, we have a better understanding how it looks like the all-electric mine, and that was actually quite a good experience for us because by that we could, with more confidence, continue the journey of decarbonization and believe that this is feasible. And at the end, I could say that bringing all the forces together and also synergy will help all of us to work towards decarbonization of the mine and reduce the greenhouse gas emissions.
Indeed. Chris, what was the impact on the costs of a battery vehicle fleet in comparison to a diesel fleet?
It turned out to be surprisingly close. We have obviously a much higher capital cost to purchase the fleet, but we found that the energy savings that we spoke about before more than offset that extra cost. We do have extra costs to put in charging bays and hire equipment, so we end up being about 6% on a net present cost basis more expensive with electric than diesel. However, there's a lot of very conservative conservative assumptions in that. And I'm pretty sure that when we go back and look at some of the charge stations we could cut out, we could change our secondary ventilation, we could go for faster charging. There's a number of areas where I reckon we could get that down to parity. And then if we ever get to implement it, I think we'll find the OEMs have been conservative, we'll get better productivity, and I think before long we'll be able to demonstrate an electric mine is cheaper than a diesel mine on top of being safer and greener.
So obviously the results of the study you've done are specific to Cosmos, but how applicable do you think they are to other operations?
I think the principles are applicable everywhere, and we would love to find another project to go and apply them to. We haven't just learnt how to do one mine. What we had to learn was how to use the equipment, and that is all applicable to any mine.
And I guess finally, what's next with the study?
Well, unfortunately, the study isn't going any further because we've had to make the very difficult decision to put Cosmos in care and maintenance. The economics have moved against us. It's very sad for all the people involved. But had we gone ahead with it, we would have gone on for a 4 execution program that would have included all the practical things about how to actually change the diesel gear for the electric one by one, how to train the people, and how to get the most out of it. And I think that we would have found some more improvements, as I was saying before. I think it would have been a really good thing. And it's actually quite sad that we can't actually do that because we're all convinced of this case. We just can't show people where it was going to go.
Yeah, extremely valuable learnings nonetheless.
Very much so.
Gentlemen, thank you for joining us for what has been a fascinating discussion about electrification.
You're welcome. It's been good.
Thank you.
Thank you.